x2 element of A, S1 less than S2, imply that f of x1 greater or equal to f of x2. Okay? So those are the basic definitions. So you can use that one now to prove that any given function is increasing on a given interval. So that's the original definition. Eh? Let's switch it also somewhere. Anyway. Okay. Are you following? Okay. But you know, this is the original. We can ask you to prove that the function is simply increasing or decreasing by using the original definition. But in calculus, when we see derivative, if you want to prove that the function is increasing, you just need to find the first derivative and then prove that the first derivative is greater than 0, then you see that it's increasing. You know already, right? You know. But if they don't ask you to go in the derivation and ask you to prove from the definition, you have to do this. And we saw a few examples last time, eh? Okay? Alright, so if the function is either, if we are saying that the function is monotone, that's something that it's either increasing or decreasing. The monotone. Okay? So we are on the same page, eh? If I give you the function now, you can prove that it is increasing. Okay, let us try, for example, let's consider the function x minus 2. Okay? Let's try to use to study the monotony of the function. Okay? So this is the function. How can I see this formula? Do you guys know how to switch off this? Those who are laughing, you know how to do it. Okay, so what's the domain? The domain of the function. So you know how to find the domain of the function. Is x element of R such that x minus 2 different of 0. Okay, that's what we found last time. Okay, so the domain of this function is R without 2. Yeah? Okay, so I can write it in form of interval minus infinity to 2 union 2 to plus infinity. Okay, so that's the domain of my function. So now I want to study whether the function is increasing or decreasing on this interval. So you can see that we have the union of 2 intervals. Okay, so what happened when we are from 2 to plus infinity? Okay, what happened? We want to see if this is not decreasing. Okay, so let's assume x be element of 2 to plus infinity. Okay, so we want to see if the function is increasing or decreasing. Okay, so if I want to prove that the function is increasing or decreasing, what should I do? Or we need to take two arbitrary numbers. Okay, so let's x1, x2 be in my interval 2 to plus infinity. Assume that x1 less than x2. Okay? Yeah? So if I assume this, what I need to prove? I need to find out whether, I need to check whether f of x1 is less or less of x2. That's what I need to find out. I need to check whether we have this or we have this. Are you following? Okay, so that's what I need to check now. So we need to have in mind that I want to check whether is this or this. So if it is this, then it is decreasing. If it is this, then it is increasing on this interval. Remember that I started with this interval. And you see from my domain, I have the union of two different intervals. Okay? Alright, so having this, let's try. I can subtract minus 2. So if I have x1 less than s2, I can subtract minus 2, and I will have x1 minus 2 less equal to s2 minus 2, and I may do the inequality. Okay? Yeah? Okay? So we have s1 minus 2 is positive on this interval. S2 minus 2 is positive on this interval. Huh? Okay? Now, if I want to take the inverse, what will happen? If I say that 2 is less than 3, 2 and 3 are positive. Now, if I say 1 over 2, how will 1 over 2 behave regard to 1 over 3? That's obvious answer now. 2 is less than 3. What will happen here? If you take inverse, what will happen? Greater. So therefore, I say 1 over x minus 2 is greater equal to 1 over s2 minus 2. Okay? Why? Because this one, because x1 minus 2, s2 minus 2 are all positive.
So why is it greater?
Louder.
Why are you saying greater?
Yes, because look, I started with this interval. Okay? 2 plus infinity. So if x for any x, so it could be s1, s2, s1 and s2. If they are inside, then s1 minus 2 will be from 0 to infinity. It's positive. If x is from 2 to infinity, x minus 2 will be from 0 to infinity, right? Yes or no? That's the question. You don't know. I say x is from 2 to infinity. Well, if I say x is from 2 to infinity, s minus 2 will be from which interval to from which interval? You don't know. Okay, that's all right. So how may I write this in form of interval, in form of inequality? There's something like s greater than 2, right? And if I subtract 2, x minus 2, are you seeing it? So s minus 2 is greater than 0. So that means that x minus 2 will be in the domain 0 to infinity. Can you see it here now? Okay, good. So that's why I say I assume from I started with this interval, and we get this. So then we have that f of x1 is greater equal to f of x2. So f is what? Is decreasing. Decreasing. On which interval? On which interval? Good. 2 to infinity. Okay? So you can do the same on the interval minus infinity to 2. From the interval minus infinity to 2, now you find out that f is increasing. Okay? Good. Alright, let's move on. So now we can do some operation on function here.
Why would you create an equal to that?
Um, why do I use a greater equal rather than equality, rather than strict equality? Um, yeah, that's the function cannot with the function. Okay, let's see. It will be strictly increasing, right? It will be strictly decreasing. If I found the derivation, of this 0, the function, the derivation can never be 0, right? It can never be 0. So, yeah, it can never be 0. Yeah. So let's do this. Strict. So it should be strict. Okay? It should be strict. Yeah. So instead of saying decreasing, I can just add the word strict. Strictly decreasing. Because when you find the derivation, okay, if you use that, the other method in the derivation, you find out that the derivation, if you derivate this expression equal to 0, you might not find any number that they call it extremum or maximum. So this also does not calculate the maximum. Yeah. Okay. So let's take it as a strict. Okay. Strict. Okay. So as I said from the definition, whenever you see the right strict, less or greater, if you want to state anything about the quantum, just write that it is increasing or slightly decreasing. Okay? But it will happen that, if you take two arbitrary elements, f of x will be equal to f of x1 will be equal to f of x2. Then in that situation, yeah, that's an example. Yeah. Actually, 2 is not in the domain. 2 is not in the domain. So the example that I can take 2 of 4. This proof should be for any. I'm just taking an example just to you to see what is happening about the inequality. So the proof actually will go for any arbitrary element x1, x2, not for example. You should not pick an example. But remember that whenever you want to put the statement for all, you need to put it for any value, not give an example. Okay? Yeah? So this, what I'm doing here is just to show the behavior that you have 3 and 4. When I reverse, you see that it's greater. It will change. Okay? Any other question? Yeah, it's strictly decreasing. No, but the function cannot be at the same time increase and decrease on a particular, on a given interval, on a particular. It cannot be. It's either increasing or decreasing. From 2 to a different example. Like you mean a different function. You can consult the function of my function. Yeah, so this is the function that I gave, right? You want me to to modify the function okay. So this function that I gave, we prove together that actually on this interval it will be strictly decreasing, right? And you okay with that? Now, understand the question. You want another function that is strictly increasing on this interval. That's what you want. Or you want me to prove that it is the same function is decreasing on the other interval. In the same interval. Okay. Exponential of x. Listen. Exponential of x minus 2. That's a simple function. Let the g of x that will be increasing on the interval 2 to plus 8. Do you know the reason why? Or do you want us to go through the two? You're all familiar with the exponential component. Okay, so this will be, this function now is strictly increasing on 2 and 1. And there are plenty of examples. This is one of them. Okay? You find? You satisfied? Good. Alright. Okay, so we can actually do some operation of the function. Yes. Y equal to y equal to 2, that's your function. So this is a constant function. Okay, you say I'm giving a function because if the way that we saw, I guess that you are reading the main note there, the lecture note there. So the way that the note actually, if you can represent the function on a Cartesian plan x, y. So y is the range, is the output already. So if you give me y, I can assume that you are already giving me the image, which is the output of the function. Okay? And this y should be actually, you can write y as the explicit function. Maybe it would be f of something of x. That's the explicit writing. Equal to 2. Okay? So when we are saying y equal to 2, actually you are telling me that my function f of x is equal to 2. Okay? So this is a constant function. And then you want the monotony. You want me to answer whether it is increasing or decreasing. Okay? A function that is constant. Is it increasing or decreasing? Is what? Constant. Is a line here. It's not decreasing or decreasing. It's a line. Okay? Yeah. X. No, x is equal to 2 is not a function. Do you know a function? Do you know what is a function? Huh? Huh? You know? Okay, we know what's a function then. Huh? A function, if you want to define a function, don't just say x equal to 2. No. If you want to define a function, you need to have the domain and what? The range and the map, the relationship between the element, and or you can give the explicit writing of the function. That's what we mean by function. And we saw that it's not every relationship or every graph that are actually a function. I think we spent more time on it the last time, so we're going to back to it. Okay, so now if I consider a set of functions, I can consider a set of functions. Okay? where now the element of my set will be considered as a function. I can do some operation on this set. Okay? Do you know what is a set? Huh? Okay. So let's assume that I have my set A, which is a set of functions f from R to R. Let's assume that. So this is just see that the way that I'm writing. This is a set of a function, and any arbitrary function. The way that I wrote it now is any arbitrary function from R to R. But more specifically, yeah, let me just, yeah. So it will happen that we can add functions, we can subtract functions, we can do the composition of functions. So on this set now, I can read two arbitrary functions on this set, f and g. Okay? Example of element of this function. Who can give me example of element of this function? Example of element. Give me an example. Element of this set. Okay. S squared minus 2. This is one function. It's a real function from R to R. F2x, it could be it could be what's the square root of absolute value of f. Okay, so those are my two functions. So you see now, the element of these things are functions. So you should not, if I tell you manipulate the element of this set, you should not be giving me x, or it should be a function. Okay? Now, I can actually now start doing the product, the addition on element of the set. Okay? So, given two elements, let f and j be in A, I can try to know what is f plus j, what is f minus j, what is f times j, and what is f composition. So those are the few operations that we can actually know about this element on the set. We can do subtraction of function, we can do addition, we can do division, we can do division f over j, we can do composition, all those kind of operations. Okay? Yeah. Okay. So look at it. But when you are doing the operation, when you are doing operation, you need to be careful. Because we know that a function is well defined from its domain to a range. Okay, so if I want to do now f plus j, I need to know the domain of f and know the domain of j. So f plus j will be defined on the domain of f intersection of the domain of j. Is it so much? Okay. So considering f is defined from the domain. Let's write the domain of f to R, okay? And j is defined from the domain of j to R, okay? And if I want to do f plus j, I can evaluate f plus j on any arbitrary elements x, and by definition it will be f of x x. Okay? But this x has to be from the domain of f intersection with the domain of j. Very important. The same goes with the subtraction. I give an example. Let's consider f, what we give now, the domain is from minus 2 union 2 infinity to r, and x we map to 1 over x minus 2, right? This is f. And let's take j. My j is from r to r. X I map to exponential of x. Are you all familiar with the exponential function? Are you all familiar with the exponential function? Okay. So those are the two functions that I gave now. And I want to do f plus j. I want to evaluate f of f plus j. So f plus j will be, by definition, if I want to define f plus j with this example now, f plus j will be defined on the domain of f intersection to the domain of j to the range. Don't see. Okay? So the domain of f is what? Minus infinity to 2 union 2 plus infinity. That's the domain of f. Okay? Now I do this and do the intersection with the domain of j. The domain of j is what? R. Expression of x is defined on any real number, right? Yes? Okay, so that is my domain, the domain of the sub function. Okay? To the range. Okay? Now I'm actually constructing my function here. So for every input x, I map to this a way to write the function. For every x, I map to. So this x here belongs to this domain. I map to f plus j of x. Okay? Are you following? Yes? And the f plus j plus x is, by definition, is f of x plus what? J of x. You can actually write it. So f of x is what? 1 over s minus 2, and j of x is exponential of x. Okay? So that is my expression now. So if I want to write it, maybe simplify, f plus j of x will be x minus 2, 1 plus s minus 2, exponential of x. So that is my function f plus j, the sum of function. And I can evaluate f of j of any numbers, any elements inside my domain. So I can ask you now, what will be f plus j of square root of 3? I'm going to give it to me. What will be the outputs? If I say f of plus j of square root of minus 2, you should be able to give it to me. Okay? But the domain, you have to be careful, because the domain of f plus j will be the domain of f intersection with the domain of j. The same goes with subtraction. If I want to do subtraction now, I will just, it will be minus, and it should be minus here, subtraction. And the domain will still be the intersection. Okay, please. So let's look at the quotient of function. Okay, so we want to do now, yes. Pardon? like yourself. What do you mean? Yes, yes, that is it. Good. So we can ask also to the question. Uh, if I want to do f of x divided by g of x, I want to make it like that. Okay? And I want to know the domain. Okay? So by definition, if I want to evaluate it, I give you a function f and I give you a function j. And I want to know what is f over j. F over j of f of x. You see? F over j of f of x. So this by definition will be f of x divided by what? G of x. Okay? Yeah? By definition. Now, but in order to write this, you need to know what is the domain of this f over j. The domain of f over j. Okay? So f over j will be defined on the domain of f intersection with the domain of j such that the j of x is different of 0. Very important. Okay? The j of x has to be different of 0. Eh? Let's give an example. Assume that f of x is s squared minus 2. Okay? And g of x is what? X minus 1. So f of x is a function, is a polynomial of degree 2. Right? And g of x is a polynomial of degree 1. So what will be the domain of f plus k? What will be the domain of f plus k? If I want to add up to do something, what will be the domain? Yes, go on the outside. No, the domain. What's the domain of